All right, welcome back, guys. In this video here, we can discuss types of data. Um, once we, the first thing we can discuss type data and how to classify data. And I think the next lesson is um, how to collect the data using different method of sampling. So in this lesson, we can discuss how do we classify data, what kind of data we have in terms of statistics. When you see a numbers, when you see a result, what was the data that we collect from, the type of data itself. To understand that, the first thing we look at is just how to know when is a number that is describing a sample size or a result of the study, or the number is describing a larger set, which is the populations. So the difference between those two will be parameter and statistics. How do we know when is a number in a study or in a example like this here or a journal, it is referring to the larger populations or just a sample size here. So we have parameter and statistics. Okay, so parameter is a numerical value that describing populations itself. And then we have statistics, another definition of statistics in general. So this would be a numerical value that describing sample size. Okay, so parameter referring to population, statistics referring to sample. So it said describe the role of each number in the following example. So there are 17,246,372 high school students in the United States. In a study of 8,505 United States high school, U.S. high school students 16 years age or older, 44.5% of them said that they text while driving at least once during the previous 30 days. This was from Texting While Driving, Versus Motor Vehicle Behaviors Among U.S. High School Students by Olson's, blah, blah. Okay, so we have several different numbers in this example here. The first one we have is 17 million. So what will say the role of this number? 17,246,372. So this is the number of high school students in the United States. So what we consider this to be the population or sample. So I would say this would be a population. So therefore, this is a parameter value since it is the population size, right? Population size of all U.S. high school students. Okay. Next number, we have 8,505. So that number is 8,505. What we say this number will be? I'm going to say this number here is referring to, in a study of this, of 8,505 United States high school students of age 16 or older. I'm going to say this is just a smaller set of a larger set. So I'm going to say this is just a sample size. So this is a statistics value, because it is a sample size being surveyed, right, for the study. Okay, let's see what else we got here. 44.5% of them said that they text while driving. So we can say this number here, 44.5%, that number is also a statistics value because it is come from the number of high school students were surveyed, right? Is another statistics because it is based on the sample. So therefore that number is statistics. So two definitions we know so far in this class referring to statistics. First definition is a more formal definition. It is saying that it is the science of planning, study, organizing, presenting, summarizing, and interpreting. So that itself is a formal definition of statistics. Definition of statistics. And And then the second definition we know in this, we just learned this lesson here, is just referring to values, numerical data, or just numerical values in anything we see. And we have to understand whether that is a sample or a parameter, right? How do we classify data? Data can be classified into two different type of data. We have the first type as quantitative data. All right, quantitative, and then we have qualitative data. Okay, so quantitative is numbers, right? Numerical data that has to do with numbers. Qualitative doesn't have to do with numbers. Well, actually, this still have to do with numbers, but the number doesn't have any meaningful in terms of the value themselves. So usually this is referred to as categorical data. Okay, all right, and let's start with the easy one first. So qualitative, usually those data consist of names or labels. All right, an example would be the color of eye colors. There you go, eye color. Eye color. Oh, I can't spell this here. Right, or your political party or affiliation, right? Something like that. Okay. Quantitative, numerical data. So that can be broken down to two further classification. So we have discrete quantitative, or we have continuous data. If it's discrete, those are the values. These are the values. The values is finite, just a whole number. Okay, and then over here we have value is infinite. Usually do a decimal number, infinite. An example of this has to do with measurement. Meaning we would have to measure to get the actual value itself. Discrete is more like countable data, countable, and then here will be uncountable. Okay. Some examples. So we have example discrete quantitative would be example. We can say that the numbers of eggs in a carton. Well, there's a fixed number of eggs in a carton. There's just no way around it, right? So that's discrete, right? Where over here, continuous. Let's say if I have to guess how tall is a person, which is height, right? And their height could be a range of values. In order for me to, I can't really count the height. I have to actually measure the height itself, and that value is a decimal number that can be ranged from 5 feet to 10 feet. We don't know, right? So there's a bit continuous that. So usually height, weight, gallon thing that like blood drawn in terms of gallon, water, gas, things that have to be measured to get the value. So after we classify data, we can also look at how to determine the level of measurement of data, and this is just for mainly just for quantitative only. Quantitative. If it's quantitative, we can actually not just mainly for quantitative. I think the first one is for quantitative. These three can be no, this is for qualitative, and these three is going to be quantitative. So let's go through that, and then we'll describe what the different level of measurement will be. Let's see. The first level of measurement will be nominal level. So this level is mainly just categorical data only. Okay. And data cannot be arranged. Data cannot be arranged in order. Okay. Like I said, example be M&M color or gender, these can be arranged in a certain order. And if that's the case, then data belong in this nominal, it will be just mainly qualitative. Okay. Next, we have ordinal level. Ordinal level will be where data can be arranged, but we can't take difference and have a meaning. Okay, so difference are meaningless. Okay, an example would be ranking and letter grades. Meaning, let's say we can arrange, A, B, C, D, F, so that we can arrange them. But we can't just say, well, what is the difference between A and B? What is that here? It has no meaning. It has no meaning, right? Because these are letter grades, meaning. So there's no difference there. We can't find a difference, and we can't make sense of it. Okay. Next, we have interval level. Data in this level here, we can arrange. Okay, so it can be arranged. There's the difference, a meaningful difference. But however, there's no natural zero starting point. Okay. And ratio are meaningless. So ratio are meaningless. Okay. So an example of this would be, what does it mean to have a no zero natural starting point? Let's say we have temperature. So temperature example in this case. So what does it mean to, okay, can we arrange temperature in an order? In order? Yes. Can we take 72 degree minus 62 degree equal 10 degree and has a meaningful difference? Yes. What does it mean to not have a zero natural starting point? Okay. Well, let's see. Temperature. 0 degree. Does this mean absence of heat? No. Right? So there's zero does not mean zero quantity of percent. Right? Another example would be, beside temperature, would be years. Right? So when we say the year zero, does that mean there's no time at all? Yes, there's time. Time still present. So there's no natural zero starting point. Next, ratio. So data at this level can be arranged. Difference can be found. And are meaningful. There is a zero starting point, natural zero starting point, and ratios are meaningful. So I'll just write here. So let's see, we say zero starting point, meaning zero indicates none of the quantity at present. Okay. An example of this would be, let's say we have height. Okay, we have class time. So these are all example of ratio levels. We can arrange the height. We can take difference between height. If we say someone is zero height, mean they are there's no height. It's ground level, right? So all those are, and then we can take the ratio between a person height to a female person height to a male person height. That ratio is meaningful. So in example 2 and 3 here, I'm gonna let you guys do this on your own, but I'll write down the answer, and then you let me know if your answer agree to my answer here. So you should pause the video in this one here, and then and try this example on your own, and then come back and check the answer here. So I'll just should pause and try this on your own and check the answer in a few seconds here. So I'm gonna go ahead and write the answer here. So this is discrete data. We have continuous data, and then discrete data, and then here we have continuous data. Again, this has to do with the fact that we have to measure the gallon of milks that cow produce a year. Over here we have qualitative, and then it's at ordinal level. Here we have quantitative, and continuous data, and then at ratio level. Lastly, we have the number of Starbucks drinks a person orders in a week. This would be quantitative, and then it is discrete, and then it's at ratio level. Okay, so check the answer, see if you got the same answer I had there.